Hello everyone and welcome once again to my channel. In today's interesting chemistry class, I'm going to show you how to balance chemical equations. We're going to start with the first one right here where we have C3H8 plus O2. They react together to give us CO2 plus H2O. I need you to understand that on the left you have your reactant. So C3H8 and O2 are your reactant, while CO2 and H2O are your products, or are what were formed after the reaction had gone into completion. How do we balance this? Let's begin with the first one before we go to the second one. If you look closer right here, you will discover that here we have three atoms of carbon. Okay, this subscript represents the number of atoms in this molecule or in this compound. You can see here we have three. Okay, we have three. It means three atoms of carbon, and attached to the carbon are eight atoms of hydrogen. Okay, for the carbon on the left, we have three atoms. For the hydrogen, we have eight atoms. Okay, and on the left as well, we have two atoms of oxygen, right? Okay, so for the oxygen, we have a two. Now, if you go to the right, you will notice that we only have one carbon atom. However, we have three on the left, which means that the carbon atoms are not balanced. For the oxygen, we have two. Okay, here we have a two, all right? But it doesn't end here because we also have one other oxygen atom, which makes it three. Okay, here we have a 2 plus 1 here. So just see this as a 1 attached to this. Okay, and we have 2 plus 1, that makes them 3. How about the hydrogen? We only have 2 hydrogen atoms on the right, but 8 on the left. What do we do and how do we balance this? Well, I'm going to draw a table for our first reaction. Okay, I'm going to draw a small table here. This E represents our elements. Here I'm going to list all the elements that are involved in the reaction. And here we have our left-hand side, while we have our right-hand side. So all the elements that are involved in the reaction are going to appear here. The first one is a C. This is our C. I'm going to draw a line here. Our C, how many atoms do we have on the left? We have a 3. I'm going to start with a 3. And on the right, we have just 1. Okay. The next one is our hydrogen, which we have here as our H. How many do we have on the left? We have 8 atoms of hydrogen on the left, and I'm going to write it here. How about on the right? How many do we have? These 2 attached to the hydrogen tells us the number of hydrogen atoms we have, and so far we only have 2. I'm going to extend this line to accommodate other species. What's the next one we have? We've got oxygen, which is our O. How many oxygen atoms do we have on the left? We've got 2. And on the right, we have 2 plus 1. Remember, this has a 1. This is just a subscript of 1 here. Therefore, 1 plus 2 gives us a 3. We're actually using the table method. This is a table method. I'm going to clean this. Actually made a mistake. So here is the table method. As a learner, is advised that you use this very method so that you can see what you were doing. Now let's try to balance them. If you check out right here, you will discover that we only have 3 carbon atoms on the left. The hydrogen atoms are not balanced, neither are the oxygen. You cannot change these numbers down here. You can't change them. The 8 down, any number that is below, you cannot change them. You can only add numbers in front. Okay, you can only attach coefficients to this element, but you cannot alter the numbers down here. You cannot alter these ones. For example, this is a 1 here, is a 2 here. You cannot change them. They must remain as they are. You can only add numbers in front of this, like here and here, but these ones below can never be changed. All right, let's try to check out the carbon atoms on the left. Since we have a 3, let's balance the one on the right. For the one on the right, I'm going to add a 3 here. I'm going to add a 3 here. If I add a 3 here, what happens? This one cancels out. It's no longer 1, but now a 3. Have you seen? I added a 3 here. It's now 3 on the right and 3 on the left. Okay, for the carbon atoms, they're actually balanced right now. But adding a 3 changes the oxygen. Have you seen? So this 3, or the coefficient, or whatever number is in front, affects the subscripts. Have you seen? It affects the subscripts. It also affects the other subscript. So for the carbon, this now becomes 3 times the subscript of 1. It gives you a 3. How about for the oxygen? We have 3 times 2. So this 3 affects the 2. And now becomes 6 right here, plus 1. Okay, plus 1, that's now a 7. Therefore, we're going to cancel the 3 here and put a 7. Okay, that is, we now have 7 oxygen atoms on the right after balancing the carbon. And you need to understand that as you add numbers in front, it's actually going to affect other atoms contained in the same compound. Okay, like here now, the oxygen has been affected. We now have to also write the new number of atoms on our table. Now we're done for the carbon. Let's go ahead and work on the hydrogen. How many hydrogen atoms do we have on the left? We've got 8, but on the right, we only have 2, which are this. So to make them the same, I'm going to add a 4 here. I'm going to add a 4 here. If I add a 4 here right now, this now becomes 4 times 2. It gives me an 8. So here now we have, I'm going to cancel the 2 and write an 8 here, because we now have 8 hydrogen atoms on the right. But remember that adding a number in front of the hydrogen also disturbs the O, because this H and O are together. This now becomes 4 times 1, right? 4 times 1 will give you a 4. And here you have 3 times 2. That becomes what? 6. So 6 here, okay, 6 plus 4 gives you a 10. It means that for the oxygen, we're not going to cancel the 7 again, and we put a 10 here. Okay, we put 10 here. We actually use this table to keep track of whatever we're doing, so that we'll understand how it's actually going. Now, the carbon atoms are balanced, hydrogen are also balanced. However, the oxygen on the right we have 10, but on the left you only have 2. Now, what do we do right now to balance it up? We now go to this one here. Remember, you can only change the numbers in front, but you cannot change these subscripts. Now, you now ask yourself, what number am I going to add in front that if I multiply that number by 2, I'm going to get a 10, as we have here, to balance everything up. And that number happens to be a 5. Okay, if you put a 5 in front of the O, it's not going to be 5 times 2. That gives you a 10. Hence, we can cancel out this 2 and put a 10 right here. You've seen they're now balanced. Now, let's count our atoms to know if they are balanced. For the carbon, we have 3 carbon atoms on the left. We have 3 on the right. Okay, this number in front indicates the number of atoms of carbon. And for the hydrogen, we have 8 hydrogen atoms on the left. However, on the right, we have 4 times 2, that's an 8, right? Now, how about the oxygen? We've got 5 times 2. Remember that this number in front, which is the coefficient, multiplies the subscript. And that gives you the total number of atoms of the element you're looking for. Here, 5 times 2 gives you 10, which means we have 10 oxygen atoms on the left. How about on the right? We've got this 3 here multiplies with 2, gives us a 6, plus 4 times 1 atom, it gives us a 10. Therefore, 6 plus 4 gives us a 10. Therefore, they are all balanced. So this is now our balanced chemical equation.